Hello, guys. Can anyone hear me there? Okay, please, if you can hear me, just confirm by chatting in the chat box. I posted in the chat box, please. Let me know if you can hear me clearly. Okay, good. Shira says we can hear you. Maria Camo says yes. Any other person? Can any other person hear me? Okay, good. So your responses are slow. We need to be faster. I need to know that you are hearing me before I can proceed, right? Yeah. So I'm Destiny Otto once again, and I'll be your host here in this meeting, in this Eclipse course. So some of us already attended, or most of us already attended the class yesterday, and the class, you could testify, was really amazing. And we really appreciated the way the instructor took out time to give us a ground on that, to ensure we are grounded in the procedures and steps for carrying out or building reservoir models using Eclipse. So today, I couldn't share this slide yesterday because of a few technical issues we faced at the beginning. So I'm going to share it right now. And I'm going to share it right now. So please just pay attention and stick closely to get what I'm about to show you about the course. So basically, this is what we'll go through. Let's run through this course details, course highlights, certification requirements, the course delivery means, method, and then the facilitators and tips to get the best out of this course. So these are the course details. These are some details or information about the course. The course is brought to you by Petrotechnical Hub, Petrotechnical Hub and TechPet Global. Actually, we're a professional training body. We carry out professional training in various aspects of petroleum engineering and geosciences related software, Petrel, Eclipse, IP, integrated production modeling, Prosper, GAP, MBAL, and HISIS, and many other softwares you can think of. Most of the softwares you can think of that is mostly used in the oil industry, PipeSim, and so many others. So we conduct this training both on personal or private or individual basis and corporately. So if you or your company intend to upskill your workers, you can invite us to an in-house training or a virtual training. We are open and available for business. So in this course, there are over 450 entries from 40 countries, right? So we have participants from 40 different countries. And then the course will span for 2 days, and we already started yesterday, and today will be the final day. And then we are starting 3 p.m. as we have already started to 5 p.m. So the course is free and it's open to everybody. So if you don't already follow us on LinkedIn or social media, or you are not in our Telegram group, later on we'll share a link in the chat section for you to join us or to follow us, just to ensure that you are updated with our programs and that you don't miss out on our full professional trainings. This is just a very short and brief course, but we carry out full-scale training if you intend to learn with us. So you can always fill our inquiry form if you want to find out about a particular thing or a particular course. Our inquiry form is will be available later on in the chat section. So these are what we'll cover in this course: the reservoir simulation data sets, reservoir simulation data quality check, and then with PVT modeling, SCAL modeling, simulation modeling workflow, and how to quality check your results, right? So we've already started much of this yesterday as he began to show us the workflow. Yeah, so about the certificates, certificates are charged at $5, but after the deadline, we extended the deadline to today, that is being Sunday, and 23:59 hours, right? So by 11:59 midnight, GMT +0 today, the payments will be closed, right? So if you have not made your payments, you have from now till 11:59. And you can still make after that time, you can still make your payments tomorrow, but then you have to pay $10, right? So the certificates are only available for those who complete the course. We'll soon upload the assignments in your Google Classroom for those who have paid. So please take note of that. So remember, the certificate will be given to those who complete the little assignments we are giving to you. Take note of that. So submission for assignments, the submissions deadline will be on Monday, 23:59. So you have until Monday to submit the assignments we'll upload today. So this is how we deliver the course. That's the link to the meeting. And then this is the link to the WhatsApp groups if you're not in our WhatsApp group or you join our Telegram group. So these are the course facilitators. We have the instructor, Engineer Joseph Oguche. We have Destiny Otto, Yunanda Miat. We have Musa Okai, Itoro Kofi, Esther Doho, Edwin Joe, Daniel Ofuebu, and Ikechukwu Obodo, Emmanuel Obasi, and Precious Okon. So that is it, guys. That is what we are. That is the guys that made up the facilitators of this course. And then these are some of the tips you need to know. Of course, I don't want to take time to go through this, as I know a lot of us are having issues with installing the software. But unfortunately, I'm thinking the version 2015 that was shared in the link isn't working, or the license probably is expired or isn't working. So if you can get your company to get a better version, or if you can find a way to just get access to a licensed and up-to-date licensed version of the software, I think it will do a lot of good. Your institution can provide you with one, or your company. Yeah, so for now, we have no free version of the software, so just take note of that. So if we do, we'll let you know. So thank you very much, and I want you to sit back and enjoy the course. Any questions before we go on? If you have questions, please use the chat box. I want to hear your questions. Okay, so I'm not seeing any question except the ones that are already answered. So about the assignments, it's just one day, right? So you have until, we may extend it, but for now it's Monday, 23:59 hours on Monday. So you just have to do your best. And then if need be, we might want to extend it, but we'll let you know at the end of the day. So thank you very much, guys. The instructor, Engineer Joseph Oguche, is a seasoned reservoir engineer with Alibotin, and we all love the way he took his time yesterday to explain every step of the way. he was careful enough to ensure that we understand every single thing and every single step he took. So you want to make sure that you sit back and you just take a good position and you enjoy the course, right? So I want to welcome Engineer Joseph Oguche, a reservoir engineer currently with Halliburton. So you are welcome, sir. Over to you, sir.
Thank you very much, Destiny. Thank you so much for your presentation. So greetings to everyone here present in the meeting. And yeah, today is the second day of this meeting, and we're supposed to be rounding up, right? Yesterday, I gave out some questions as assignments. I asked, I think, Destiny or one of the facilitators to take note of those questions. Sorry, I didn't write them down myself, although I can still remember some of them, but I was expecting that those questions would have been compiled.
It's okay, sir. We have done that already, sir.
Okay, sir. We have. Okay, yeah. So if you have the slide, I think you should put it up. Let's take the next 5 minutes to do a very brief discussion, 5-10 minutes thereabout, depending on the number of persons that we have. Now, if you have something to say as regards providing answers or solutions to the questions, I don't know if it would be allowed, Destiny, that you unmute any of them. Let's just have a discussion for the next 5 minutes. If you want to talk, raise your hand. The moderator will, allow you to talk. And then if you have a question, also feel free to ask your question. Yeah, so
okay, guys, you can unmute yourself, but ensure that there's no sound in your noise in your background, and ensure to mute yourself when you are not speaking, right? If you have a question, please just go on, unmute yourself and ask.
So please, Mr. Destiny, maybe you should do a favor of projecting the question.
I didn't get you, sir.
The questions, those assignment questions,
yes, sir.
Did you prepare them on a slide? I thought you said something like that.
No, they are not on a slide, but we wrote them down and we'll share it with them later on after this class.
Oh, okay. Oh, okay. All right, fine then. So whoever has something to say, a question, 5 minutes, we have 4 left now.
All right, good afternoon, everyone.
Thank you.
Good afternoon, Mr. Joseph. Thank you for a wonderful class yesterday. My name is Sunday. I think I could just remember one of the questions for the assignment. I think the last one, which was what parameter in your simulation are you going to change to double the total oil in place? I think something like that. So just like to share a few I can think of. I think one thing you can change if you increase the grid size for the vertical grid, which is 20, if you increase that to 40, I think that's going to double the total volume. That's one I can think of. The other one I can think of is also if you increase the distance between the datum point and your water oil content. What we did yesterday was to have 1,600 as GOC, and WOC was about 2,000 thereabout, which whatever that value in between is, which defines the total volume of the reservoir, like the total oil volume. If we double that, I think that's also going to double the volume of oil. That's my thought. And a question I asked yesterday was, that's my answer to that assignment, but I have a question, which is, yesterday you used a multiplier of 0.2 to convert from the vertical, from the horizontal permeability to the vertical permeability. That's multiplied by 0.2. But the first data you loaded, what you add was actually 0.1. So it's like, it's a kind of maybe a rule of thumb, or there's something that actually will tell you your multiplier. How do you get your multiplier? So that's my contribution, sir.
Okay, yeah, that's a very good one. Thank you. Any other person before we forge ahead? Any other question? Any other person? Oh, okay. So if that's the only question we'll have, I think that would be good enough as well. So, sorry, can you reduce the noise, please? Okay, sorry about that. So I want to quickly get some pictures from the internet that I can project, so that I can explain one or two things better. Okay. So can you see my screen now? Can anyone see my screen?
No, sir.
Okay, not yet. Okay. Okay, I'm trying to share it. Downloads on the just a moment. Okay, so you talked about using a multiplier. The multiplier you are referring to, is it the PAM-Z multiplier? Is it the permeability?
Yes,
if you can hear me.
Yes, is the PAM-Z.
Oh, okay. Okay, so you are asking why we use the 0.1, is that?
Yes, the first data you loaded when you were showing us how to do it was 0.1, but eventually when we're doing it, we use 0.2. So it's like, what's determined what you actually use?
Aha, that's fine. That's very good. Normally, to have a proper value for your vertical permeability, which is also referred to as KV/KH ratio, all right? That is the ratio of your vertical permeability to horizontal permeability. It's normally determined from well tests, okay? It is normally determined from well tests. But in the absence of well tests, you can use any good guess initially, okay? And it's a rule of thumb that vertical permeability would be between 10% to 25%, depending on the quality of the reservoir that you are working with, all right? So between 10%, which is 0.1, to 30%, which is 0.3. And it's something that you're going to perform adjustment on when you are trying to do your history matching, because what it actually affects directly is your fluid mobility, okay? It does not affect your volume, all right? So at the point of initialization, what you use for your vertical permeability may not have so much effect on the result of the simulation until we begin to talk about mobility of fluid, either for history matching or prediction, okay? Now, the other thing you also mentioned, if I remember correctly, has to do with datum depth, shifting datum depth so that you can adjust your reservoir volume. Well, you asking those questions, first of all, and your contribution shows that you followed closely in yesterday's meeting, and I'm happy about that. For talking about datum depth, first of all, you need to understand that the datum depth that we talked about yesterday is basically a depth. It's simply a depth in your reservoir where a pressure measurement was taken from. It's just a reference depth. You all hear me? Can everyone hear me? Okay. Okay.
Yes,
okay. So basically it's a reference depth. It's a reference depth. So it could be anywhere. It could be at a depth of 1,000 feet. It could be at a depth of 10,000 feet. It does not change your results. I mean, it does not change the fluid that you have in your sand. But then what affects, maybe what you meant to say is the contact depth, talking about your GOC and OWC. So look at this picture. If you can see, can you see the picture on the screen right now? Contact. Can everyone see it?
Yes, sir, we can see it.
Okay. All right. So I'm going to use the mouse to point at the top of this sand, which is the top of this formation, where below it you begin to have hydrocarbon, and the first hydrocarbon there is gas. So this is the top of the reservoir, and then at this point you have your GOC, which is the gas oil contact, okay? And then the next contact is your OWC, which is the oil water contact for short. So if, I mean, just by looking at it, it's obvious that if you move this contact deeper into the sand, maybe to somewhere here, it will reduce the thickness of the oil column, and the column for gas will be increased. Am I correct?
Yes, sir.
Okay. Now, the same way, if you move it up towards the top of the sand, the oil column is going to be increased, all right? So what this simply means is that if you move your fluid contact, it's going to affect your volume. It's going to affect your volume. In fact, it's one of the very critical parameters that affect your reservoir volume. So you get to see, you know, the geologists, they work very hard to ensure that the correct information about the contact depth are captured, because that would go on to affect just about everything that has to do with your reservoir study, all the way from technical study to economics, okay? So contact is one of those information, one of those parameters that will affect. So maybe you saying datum depth, you are trying to say fluid contact. So I have just tried to differentiate them so that you get a clear understanding, okay? Now, if you go on to look at this equation, which is equation that many of us are familiar with, all right? It's basic reservoir engineering, the Stoic equation. This is used to calculate fluid in place, fluid or hydrocarbon originally in place, in this case, oil. And you have a product of area and thickness and porosity and oil saturation, okay? And then if you divide it by the formation volume factor of the hydrocarbon, in this case, oil, you take it to stock tank condition. So that's why you have this ST here, the stock tank oil initially in place, okay? So what this equation is telling us is that all these parameters here are very important when you are looking at your reservoir volume, okay? Now, you also mentioned about increasing the grid size. Well, on no account will you be required to increase the grid size once you have been given, once it has been given to you by the geologist. You can't touch the grid size. I am talking about the extent this time. But each cell, each grid cell block, maybe you want to adjust it. And if you adjust the size of each grid cell block, it will only affect the number of cells that you have. It will not affect the total area covered by this grid. So this means that you don't have control over this one. Let me go back to this grid so that you understand what I'm saying. So this entire block here is what I am calling the grid. But those tiny boxes that you have, you know, the reservoir grid is split into cells. So you can actually adjust the sizes of these cell blocks. You can make it bigger, which will reduce the number of cells that you have. You can make it smaller, and that is going to increase the number of cells that you have. But you want to be careful with the number, because if the cells become too much, it takes longer time to run your simulation, okay? But adjusting the size of the cell blocks will not change your volume as long as the area covered by this grid remains the same. So the next thing, the next parameter here, which is the height, talks about the thickness of your hydrocarbon column. For instance, in this case, we're going to be talking about the thickness of the oil column, the thickness of this grain region here. That is what this H is going to represent. So it means that if you move this contact up, your H is going to increase. If you move it down, your H is going to reduce. And that will go on to affect the stoic that you have here. The same thing goes for porosity. If you have a high porosity or a low porosity, it's going to affect your volume, okay? This can be adjusted, this can be adjusted. If you think it is a problem, sometimes you can perform what they call sensitivity on all of this to go on to QC your model and ensure that you capture the same stoic that has been calculated from the maps or from petrophysics. And we also have your oil saturation. What you have here is actually 1 minus water saturation, which is the same thing as oil saturation, okay? So if you adjust your connate water saturation in your simulation, it's going to affect the results that you get, okay? So if you increase your connate water saturation, then the oil volume will reduce. If you reduce your connate water saturation, the oil volume is going to increase. And then finally, we have this other property here, which is the formation volume factor of oil. If you increase it, then your volume will drop. If you reduce it, your volume will be high. All right, so that's those are the properties. I was expecting someone to answer that question with this equation. It's a very important equation when you are doing working with your reservoir. All right, we can move on from here now. I'll go back to the simulation model, exercise 2. We're going to continue from here. Now, today, we're going to add wells to our simulation model. I am going to add one well, just to show you how to add one well. Then you're going to practice by adding more wells. Now, the number of wells you add or that you're going to add to your model, I don't know, but I'll give you a technique that you can use to determine the maximum number of wells that you need to add to your simulation model as we progress. Okay, to add your wells, you come to data and then you come down here to the schedule section. You can see that it is empty, and that is because we don't have any wells added to the simulation yet, okay? But then, where are you going to add the wells? That is the next question. Because the grid is quite large, you see? So where do you want to add the wells here? Are you going to put it at the edge here, where you have this green color? Are you going to put it at the center where you have red? Can anybody try to give you an answer? Looking at this grid, where would you want to position your well? Can anybody try? No one? Okay, let's go on then. So that's one of the interesting things about reservoir engineering. Please, Destiny, is anybody typing something? Are there answers?
I didn't get that, sir.
Is anybody sending in answers? Okay, I'm seeing now. Someone says center. Someone is saying where gas and oil column are thicker. Okay, that's fine. Okay, you can keep your answers coming in, okay? But we are going to look at it. You see, that's one of the interesting things about reservoir engineering. First of all, as a reservoir engineer, you hold the position of a manager, even if you're not given that title. You're a manager. You practically manage almost everything that happens to the hydrocarbon assets. Everyone depends on you. When the drilling engineer gets on the field, he doesn't know where to put the hole, doesn't know where the oil is. The reservoir engineer will tell the driller, you know what, put this well at this point. This is the depth that you are going to get to. When you get to that depth, this is the area that you are going to put your perforation. The petroleum economist doesn't have anything to work with until the reservoir engineer makes a forecast and tells him, you know what, for the next 5 years, this well will be in production, or this field will be in production. These are the numbers. This is what we expect to produce per day. And at so time, we are not going to have production. We need to spend some money to do some maintenances, to put some injector, to do some workover and all those kind of things. So you are trying to see the future from your simulation model, all right? The process guy wants you to tell him or her, this is the pipeline size I should use. This is the back pressure that we expect to have at the separator. So you're just at the center, making use of different engineering tools. Reservoir simulation is only one of them, right? So you have nodal analysis, you have decline curve analysis, you have PTA, and a whole lot of tools that are available for you. And the good thing is that, well, this might just sound like a basic training, yeah, but you know, down the line, you remember that, okay, you have done this, you have done that, little trainings here and there, you combine them together someday, and then you see the beauty of it all. Okay, so we're going to look at how to position our wells, for instance, for example, the location and the depth where to perforate in your reservoir. So I'll go back to, okay, someone is saying something here. Okay, still trying to answer the same question. All right, we're back to Eclipse. This is the schedule section. And to add a well, let's say basically you need 3 different keywords. Remember that to insert the keyword, you make use of this button. So once you click on it, these are the keywords that are available. Sorry about that. So these are the keywords which are available in the schedule section. So the first thing you want to do is to insert the well specification keywords. I'll tell you what that is, but let me go on and click on the apply. The first thing you do, event type, you select the event type, and you come here to select the particular event that you want. So to define wells, groups of connection, that is an event type. The well specification is the keyword that we want to bring in now. If I click on this button, it shows me the actual keyword. And then if I toggle it back up, I begin to see the description. So whichever one works for you is fine. Once you select the keyword, click on the apply button, and you can see it is inserted here. I won't open anything yet. I'll just go on to insert the other 2 keywords that are needed. This is the second one, well connection data. I'll click on the apply button. And the third one is well controls and limit event type. What I want to insert is a production well. So I'll select production well. I'll click on apply, but because it's the last keyword I want to insert from here, I'll just click on the OK button. Now we have inserted 3 different keywords: the well specs, the COMDAT, which is the completion data, and the well control, production well control keyword. So we're going to enter information in all of this now. I actually want to be on this first one. Obviously, I can't go back there, so let me just delete this one. Okay, so we're back to the well spec keyword, and the first thing they are asking you is the name of the well. Let's call it P1. That's production well 1. Group, it's in the production group. Now, the I location and the J location need to be specified. Specifying a location is simply specifying the grid cell where you want the well to be located. So how do we get the grid cell? We need to make use of a post processor, one of those applications I talked about yesterday. So we'll come here to the simulation launcher, and then we can find Floviz, which is a post processor that is used to visualize your grid. So I'll click on it. It's a separate app on its own, just like you have Office, you have Floviz. I'll click on the run button, and the Floviz app is going to be launched. So just wait a few seconds more. It's supposed to be up by now. Okay. Here it is. It's loading. I think I have too many things open. So, all right. Let me maximize it. So we'll have Floviz. Go to File, Open. I want to use E300 to open it. I'll just go on to my folder, which is exercise 2. And this is what we are trying to bring in. You see, the type of file, it is e-grid file. If you saw that, e-grid file. So that is the grid file. So I'll bring it in here. I'll click on the OK button, and a few seconds more, you have it loaded. So this is the grid that we modeled in the Eclipse office yesterday. We did not view it. Let me zoom it a little bit. And I can use this button here, to increase the thickness. I'll click it a few more times to make it thick enough, and it's even going to bring out the structure to make it clear. All right, down here you have a legend. This legend showing blue and red colors is called active cell. So the blue cells are the active ones. The red cells are inactive, this one's here, all right? Now, normally there's a way to cut off this kind of cells that you don't need, but that's not part of the scope of this meeting, so I'll just pass. But we can run the simulation the way it is anyway. We ran it yesterday. So the blue cells, obviously, is where we have hydrocarbon. Those are the, that is the reservoir. That is where we have porosity and permeability and all those kind of stuff that, that the reservoir engineer is interested in. So we're going to focus on this area and locate our well here, okay? Now, the next thing you want to do is, okay, these are just active cells, but do we have oil here? Where are the oil? Okay, where do we have the oil? So that is what we want to go on and look at now. Is it the blue ones or the red ones? Sorry, the red ones are the ones we're interested in. The blue ones are inactive. All right, there's a button here, up here, if you can see. If I click on this button, it shows me some other properties that can be viewed on this grid, all right? There are a couple of them. The one I want to view is, let me start with saturation. Can we find saturation? I can't find oil saturation. All right, if we can't find oil saturation, let us use permeability. That's another property that you are going to need, okay, to properly position your well. The oil saturation is not showing here because we did not request for it. Remember, yesterday we requested for FIP. At the initialization section, we entered FIP is equal to 2. So if you want to request for oil saturation, still on that line after FIP, just put soil, S-O-I-L, in capital letters, S-O-I-L. You can note that somewhere so that in your own simulation, you can include it. But let's use permeability, Perm X or Perm Y, any of them. So if I click on Perm X, now we see the distribution, all right? We see the distribution of permeability. And if you look at the legend, the blue is telling you that permeability is around 2.5. The red is telling you that permeability is around 5.0 millidascal. All right. So you want to look at it closely, and I think the distribution is even here. So we may not really be able to determine. Let's go back again and try porosity. If porosity is has a better distribution, we have something close to that. So the same. So saturation would have been better. In your simulation, please include saturation and then come here to view it. Where you have oil saturation, drop it there. Drop your well there. Now, it may be at the center. Some of our friends here are saying that the wells should be at the center, but it's not about location. It's actually where you have oil saturation, okay? All right, wherever you have selected to put your well, yes, I am going to provide the data. Yeah, I'm going to provide the data. Someone is saying something here. I think someone should remind me. I'll come back to that later if it's meant for exploration wells, something like that. We'll come back to that. Okay, so whichever location you have decided to place your well, as a matter of fact, it's better for people, for you to have independent different locations. Put your well location independently so that it won't be as if I have told you, because one of the tasks that you are saddled with as a reservoir engineer is to look for the best location, an optimized location for your well. So that's assignment number 2, assignment for day 2. Yeah, assignment number 2. So you're going to look for the optimal location for your wells, and you're going to tell the number of wells that you are going to use, to produce this field. All right. So Destiny, please take notes. Probably this is how you are going to score your students, and maybe that will be a second round of contest. I don't know how you intend to do it. Okay, but
okay, sir.
But the objective, please take notes. The objective is that if you can use the minimal number of wells to get the maximum production from your field before abandonment. Okay, so that's the objective. So if, for instance, Mr. A uses 10 wells to get 1 million barrel of oil in 10 years, and Mr. B uses 3 wells to get 1 million barrel of oil in 6 years, I mean, you know what the result is, right? So Mr. B is doing better. So use the minimum number of wells to get the maximum number of production and in the shortest possible time. So you have 3 different constraints there now, all right? So talking about the maximum number of wells, I'll tell you how to determine that. I'll tell you how to determine that, but let's go on to put a well here. Let's say I want to put my well here on this cell. I want to zoom, so I'll need this tool behind. So let's say I want the cell, the well somewhere here. So once I click on the cell, just look down, your bottom left, you see the address of the cell. We have 4816.1. So your X, on the X-axis, it's 48. On the Y-axis, it is 16. You can write that somewhere. 4816. I'm trying to put that down as well. And 1, because it is the top layer. Okay, it is the top layer. How many layers do we have in this model? Do we remember? Anyone? Okay, if you can't remember, well, that's one of it, like I said.
20.
Okay, 20. Yeah, those are one of the things you want to note when you are trying to describe your model, when you're trying to understand your model. That's the first thing, that you do. You review your model. There is a tool here. Is it this one? No, not this one. One of these buttons here. Yeah, this one. This one that is showing layers of elements, different elements. Okay. So you can see the number of layers that you have on the K slicing. IJ, you have 67 cells in the I direction. You have 49 cells in the J direction. And the K direction, you have 20. So that's 20 layers. So we want to determine which layer to perforate. Which layer do you think we should perforate? That's what we want to go on to look at. First of all, let's go to that cell. I'm using this to move.
Well, I don't understand.
What don't you understand? Okay, I'll close this and go back. This is our grid. Everything is showing like a block. I mean, the entire block. And we have selected a cell, 48, 16, 1. Okay, so the well is going to hit the reservoir at that point. But where do we want to perforate? That's the next thing. That's the next thing we're trying to do. So I'll use this button, and this is just like a filter. Let me call it a filter. So you can view any particular layer or cell by using this filter. So on I direction, we have 48. So this is 48, all right? The I direction. If I select the J direction, which is 16, it just takes me to that exact cell, okay? So this is my cell here, the red one that is selected, isn't it? So instead of selecting numbers, I was just sliding this. It's the same thing. It will still slide and filter it to where you want it to be. But I guess this one is easier, okay? Just select a cell and then the surface, the I and the J. So we're now left with the K, where we want to perforate, where we want to expose the reservoir to the well, where we want the fluid to be coming out from. So again, if you look at saturation, you will see the layer that has the best saturation for you. For here, we are looking at what? Porosity. You can use this button to change the property that you are looking at. So we have porosity, water saturation is not even here. You can call for all of that when you're trying to build your own model. But let's say permeability. Permeability is a very important property when you're trying to open your well, open your reservoir to the well. All right, so let's say looking at what we have here, I want to target these two layers that have high permeability, all right? So those two layers are layer what? Who can tell me what layer is this, the first one and the second one? If you can see my screen, those two layers are what? Anybody? Well, if you click on any of the cells, come to the bottom left corner, you are going to see the address. Now, the layer I've selected is 15, and the next one, 16. 15 and 16. As a matter of fact, you can perforate more than 2, okay? We can even go from, let's say, from 5 to 15. All right, depends on what you are trying to target. We don't have the oil saturation keyword here. If not, would have seen where we have oil exactly and where we have water, so that you don't go and perforate water and you begin to produce water, or you don't go and perforate the gas layer when what you want to be producing is oil. So again, go on and ensure that you include those saturations in the results that you want to see. SOIL is for oil saturation. SGAS is for gas saturation. SWAT is your water saturation, SWAT. So take note of those three keywords, add them to your initialization section when you are reporting solution alongside FIP. Okay, so this is how to view your grade, and we have determined where we want to locate our well. So we are done with the flow vis. So I'll now come here, back to the schedule section. So P1 is my well. The I location of the well is 48. The J location is 16. So all these white boxes, it is mandatory that you fill them. The yellow ones, it's optional. You may leave it blank if you don't have any information to add. And especially if you're not sure of a particular data, don't enter it if the box is yellow. So the preferred phase, it's an oil producer. So I'm going to select oil here. And that's it. That's all I need from here. Once I am done, I'll just say apply. I'll go back there and bring in the connection data. So apply that. You ensure that the name is consistent. P1. Here you have 48 and then you have 16. Remember, it's a yellow box. You can leave it if you don't want to put anything there. But the white box is very, very important. You must fill it. If you don't fill it, you won't be able to progress. So where do we want to perforate? That's the next thing here. We said 15 to 16. I don't know what is there, okay, because we couldn't view the saturation. But let's just put a random K value, K upper and K lower. In your own simulation, ensure that you put the correct information. So what I want to do is I want to put between, let's say 12 and say 18, all right? So I have put 12 and 18. I want to put a wellbore ID. A wellbore ID, can someone convert 0.6 inches to meters? .6, or better still, I can just change this one to inches from here. Or feet. Let me do it in feet. Okay, 0.6. You can also note that somewhere. Okay, 0.6 feet for my well bore. And that's all I want to put here. Please take down this information. All right, I just applied. And I want to add the last keyword, which is the control keyword. Again, for P1, ensure consistency. So I want to control it by oil rates. And what oil rate do I want to be getting? Let me just put something like 200 cubic meter. Let's see. So because I'm controlling by oil rates, I'll just enter information for oil rate here. And I'll leave everything else blank. Yeah, for now. So once I click on the apply, I'm done adding a well. Now, this well is going to produce for just 1 month, only 1 day, 1st of January 2021. Okay, but I want to add more dates. Let's say 1 year, 2 years, 3 years. It depends. I'll come here to, is it time? Yes, I want to insert time. I want to insert the time monthly, okay? Every month, 1 month, okay? And how many 1 month do I want to add? If I put 12 here, it means that is not clear. Please let me know. Okay, let me try to use another method. Maybe that way it will be better understood. instead of saying month, I can actually select day. And I can say I want 28 days to make a month. And how many rounds of 28 days do I want? If I put 12, that's a year. If I put 120, that's about 10 years. So let's go with 10 years and let's see if the model can do 10 years, if the well can do 10 years for us. So just click on the OK button. Now you have all of these dates populated. So from 2021 to 2030. Yeah, that's about 10 years, right? Okay, so I'm going to click on the apply and then I'll close this. Do you want to? Yeah, yes. That's it. Selected, we don't have any results selected here. There are a couple of results that you can pick from. You can pick your field oil production rates, your well production rates for oil, water, and gas, and all of that. I don't want to start going through bringing them in one after the other. So I want to import an existing result file. It's called summary file. So I'm supposed to find a summary file here. Summary file. Include file, summary. I don't have a summary file. Wow, that's bad. Okay, so that means we have to go through it one after the other then. So for fields, if you select the phase oil production rate, you see some information here. So let's say you want a field oil production rates, add it to list. You can do for gas, field gas production rate, add it to list. You can do for water, field gas, water production rate, you add it to it. You can do for wells. So let's say for wells, let's do the same thing for wells. Oil production rates, gas production rates, and water production rates. Okay, I think that's okay. Everything you have selected are here. We may need to add more, but let's try running this for now. We just take it. Yeah, pressure, field pressure. We want others pressure, field pressure, yeah, FPR. Maybe gas oil ratio as well, field GOR. Okay, let's work with this. So if I say close, it will prompt me to save. I'm going to save, and that's it. Write data. So I have added well, I have added my summary information. Now let's go on to run the simulation. Yesterday, we came here to add data sets. I think this is the data set. So now I am going to run. So you wait a few seconds for the simulation run to complete. Now, another thing you get to notice quickly is that the simulation run kind of took longer than what happened yesterday. Now, because we have a well and we have more result points, that is more dates to run the simulation, not just 1 point anymore. So it's a little bit longer, but it's complete now. Okay, it's without errors. So we are done here. So the next thing you want to do is to view your results. Yesterday we viewed the results from here. All right. We viewed it from the PRT file. Now there are more results now than what we had yesterday. Anyway, your PRT file, this is a PRT file, okay? It's going to carry the volume of fluid you have after initialization, okay? But this is not what we want to look at now. We want to use this button here, the results tab, to view our simulation results, the performance of the well and of the field. So what I am going to do, I'll come to File, Open Current Case Summary. I'm going to select this button here that says Read All Vectors and Load. So in a few seconds, it will load all of the results into the post-processor, the result post-processor, or the result viewer. We only selected results that have to do with field and well. So these are the field results we selected. These are the well results we selected. Okay, so we're going to plot these results now. The standard rule is to plot 4 different graphs on a single chart. Now it may be 2, it may be 1, depending on the type of results you are looking for, and that will have to do with your simulation objectives. But in this case, I want to plot field oil production rates. This is our field oil production rate. If I click on this button here, it will create a new slot for another results chart. So I can put GOR there. By double clicking, it plots. I'll click on this again, and then I can put water rate, and now I can put pressure at this point here. Let me change the scale of the pressure so that we can understand it better. I want it to run from 0 to say 500. And I click on the OK button. Okay. Or should I go back there and make it to 300? Let's say from 0 to 300. Yeah, something like that. Okay. So we have these results. And is there anything else we can add? Okay. On this GOR chart, yeah, it's by way of showing you what you can do with all of these commands. I can right click on it and set it as active graph. If you set it as active graph, you see something like a yellow border around it, telling you that your focus is on this graph. I actually want to put another chart, another plot on it. So I can simply come here to gas rate, and I'll say add to current graph. Now you see it's added. So we have 2 different graphs plotted on that side, 2 different plots on that graph. Okay, so these are the results we have. And what you are going to notice here, the oil production rate, is that you started with around 65 cubic meter as in terms of volume per day now, about 65 or 62 cubic meter. And it started dropping up to, what date is this? We are viewing this in days. You can view it in dates. I'll come to view and select X axis and change that to date. Okay, it has changed it for this one here. Let me set this one active and do the same thing. Okay, dates. So somewhere around the okay, it's still January 2001, but a later date, January 2021. Okay, but at a later date in the month of January. Is that January or is that 2021 or 2022? I think this is 2022. 1st of January 2022. Yes. From there on, you have a constant, almost a constant production rate of 40. So it dropped from almost 70 cubic meter to 40 cubic meter per day. So between here and here, what happened? Why did it drop? And the pressure that we have, I mean, we still have a very good pressure. The pressure has not dropped so much, but production dropped, even though we have 0 water production rates. This plot here is your water production rate. So we have 0 water production rate, and pressure is good. And what happened here? Something must have happened. So that's another thing you want to look at. You know, it's those are the things you put into consideration when you are trying to develop your field. Maybe the location of the well is not good enough. I don't know. I'll leave down for you to work to battle. We can also get some information from the GOR. GOR was reducing. What does that mean? And all of a sudden, the GOR increased. So what are the things that could be responsible for that, for GOR to increase? What are the things responsible? Is it that the reservoir pressure has dropped that low to the ball point pressure? Is it that we need pressure maintenance? What type of drive mechanism do you have in the first place? Is it expansion drive? Those are the things you would have taken notice of before you go on to run simulation. That's where the talk comes in, that reservoir simulation is a tool, but it's just a small part of, you know, the whole, which is reservoir engineering. So you need to understand your reservoir engineering. Now there are some, this thing that looks very simple and we're calling it basic. It might even require that you go back to Tariq Ahmed to start reading 1 or 2 stuff. Okay, someone said gas coning. I don't know. I mean, it's your work. It's now your own personal challenge. Work around it. Use Eclipse to find answers to this problem. Okay. Now, that said, there is one more thing that I am going to include. Okay. So let me minimize this one. I'm not going to close it. I'll go back to data. I'll go back to summary. And I'll go to field oil production total. So I want to add this keyword, FOPT. I'll tell you why I'm adding it, and this is going to be the last exercise. And I'll give you the assignment that I want to give you before we end the class. So FOPT, I'll add it to the list. I'll close it and save, write data. Okay, I'll close this now. I want to go back to run the simulation one more time so that we get results for FOPT. So this is it. I don't need to add data set again, it's already there. But to be sure, can still go on to re-add it, but you don't have to add it again. So I'll click on run. Let's wait for the second run to complete, and I'll show you the reason I added that FOPT keyword. We're just going to wait a few seconds for it to run. While we are waiting, if you have a question, please come up with it. Come up with it. Let's quickly look at one or two discussions we might have before the end of this lesson. Any question, any contribution, anything at all, let's discuss. Okay, the simulation is complete. Any question? I'll go back
here. Someone is asking if you can run it from the office.
Yes, you can. You can actually run it from.
If you want to ask a question, please raise a hand. I will unmute you. Okay, sorry, sir. Go on, please.
Yes, you can actually run it from office. Now, the reason I am particularly showing you how to run by adding data sets is that a lot of after installing, if you are able to get your Eclipse working, you might be having license issues when you try to run from office. Okay, running from office is like the simplest part of the whole thing. You just to click on it and then you click on go. Okay, and to begin to run. But you might be having Eclipse license issues. So if you're having Eclipse license issues, just simply go to your simulation launcher and add the data set from there. So that one always works. So that's why I just want to focus on that. Okay, someone is saying, what is the reason for saying FIP is equal to 2? Yeah, you can use FIP is equal to 1 or up to 5. And for FIP, it does not really have a clear effect. But when you get to using basic, like there's a place we wrote basic is equal to 2. When you put basic equal to 1, you want your result to be reported, I think, daily, 2 monthly, 3 is like saying quarterly or so, 5 is per annum. It's just like reporting frequency. But FIP is just information you get at one single point. So it may not really have effect, but you cannot just put FIP. So just say FIP is equal to 2 and leave it like that. It's not a big deal. Okay, I'll go on again to open current case summary, load all vectors, and you wait for it to load. Yeah, now that the load is complete, I can expand this. And this is the keyword, FOPT. I want to plot it on this one, the oil graph. So I'll say add to point graph. And this is my FOPT. The left axis is for production rate. The right axis is for production total. So how much have we been able to get from this field with a single well? That's why I added this one. With a single well, what we have is what? About 13 or 13,500. Let's use this button to get the exact value. If I click on it, it's going to show this data in a tabular form. So I just scroll all the way down for FOPT. And what we have here is 132,147.44. So what you are going to do with this information is this. Create a table. Please take note of what I'm telling you. It's a very good information. Just create a table. Number of wells. Number of wells. And on the other column, put FOPT or recovery, whatever term you want to use. So when we have one well, what is our total production? 132,147.22, if that is correct. So you're going to add a second well, go on to determine the total number of fluid produced. When you have 3 wells, what were you able to recover with 3 wells, okay? So once you have all of this information, you can do it up to 5 wells or 6 wells, it depends. Once you have this information, please go on and make a plot. Go on and make a plot. You're going to make a plot of what again? You're going to make a plot of on the y-axis. You're going to put number of wells. So on the y-axis, you're going to put number of wells. On the x-axis, they're going to put FOPT. FOPT. So by the time you plot it, you see the point coming out. So use Excel, connect the curve, and the more wells you add, normally, the more wells you add, you're going to be seeing the curve rising. It will be rising until when you get to the optimal number of wells, it becomes a straight line. So what it means at that point is that no matter the number of wells you add, your recovery will not increase more than that, okay? Now, if you will, go online, check Google for what is called a creaming curve. Yeah, so that's the name of the plot you are trying to create, a creaming curve. Read about creaming curve, you know, you're going to get more explanation, but this is how to get a creaming curve. So your results that you, after your work that you would like to see, part of the tools assignment, create a creaming curve. Show us the maximum number of wells that you have used and show us the optimal production that you're able to recover from your simulation. So that will depend on how well you place your production wells. It will depend on how your perforation, where you have perforated, your perforation interval and all those kind of stuff. Okay, that is all. This is the end of this meeting and the end of the class. If you have any question within the next few minutes, please let us have your questions. And if not, Mr. Destiny, over to you. Thank you.
Okay, thank you so much, sir, for this wonderful class. Guys, if you have a question, feel free to raise a hand. Or I think I've enabled participants to unmute themselves, so you can unmute yourself and ask your question right now.
All right, good afternoon, everyone.
Good afternoon.
Good afternoon, sir. Thank you for a wonderful class. My question is, how can you possibly use Eclipse to simulate horizontal work? Because the place where you input perforation, so just a point, so just a place that you can put the top and bottom. And in case of horizontal work, then you're going to have to change that axis. It's probably not going to be in the K anymore. So that's what I would like to know.
Okay.
Can you use it and how do you do it?
Okay, let me quickly touch that. Actually, that is totally out of the scope of this meeting. But it's fine because you have asked. Let me just quickly touch it. Okay. So you have the well name, and you have the I and J location. Okay. Now, when you get to the connection data, what you notice is that you have the same I and J, the same values for I and J location, but the K upper and the K lower have changed. All right. So this is like the deepest parts, or the deepest parts of the reservoir where the well can get to. Okay. Now let me go back to PowerPoint for a moment. Let's assume that this is actually a horizontal well. Let's just take our mind away from the fact that it is a chart. Yeah, someone pointed out correctly that animation, that FOPT is supposed to be on the y-axis and number of wells on the x-axis. That's correct. So you put your FOPT on the y-axis and number of wells. But again, like I said, for a moment, let's say this is a horizontal well. Okay, so it goes from the top at the surface, which is I and J, and it hits here, which tells you your K upper and your K lower. So that's like the deepest part of the reservoir where your well can get to. But the well continues actually. It continues entering the reservoir, but it's not going deeper, isn't it? So what this means is that as you're going deeper, as you're going into the reservoir, depending on the direction to the right, in this case, your K upper and K lower is not changing, but the well is actually penetrating other cells. So that's what you are going to simply model when you get here. So you're going to add another connection data. So I'll just come here to add this one again. All right. Ensure that you retain the name P1. The I and J, the K upper and K lower are going to remain the same. What is it again? I think 12 to 16, if I'm not mistaken. But the I and J will now change. So if what you have before was 48 and 16, I don't know the direction you want to go, but it can actually change to 49, 16. Okay. So, well by ID 0, let's go back to the well by ID and put 0.6 feet. Okay. So this is it. Now you are still entering the sand, but you're not going deeper. You are only changing your I or the J. I don't know the one, but of course, if you want to put a horizontal well, that's a very good question. You might want to try a horizontal well in your simulation. So just select the direction you want to go from FlowVis. Mark out all those cells. And as you are adding more connection data, you keep your K upper and K lower constant. You begin to change your I or the J depending on the cells that you have selected to penetrate the reservoir with the well. Okay, that must have answered your question. Any other question? And please, I also want to point out, this goes to you, Destiny, and your team.
Okay, sir.
All right?
Okay, sir.
Yes, that these videos, you talk to your people. These videos, almost ran into a trouble with Schlumberger, right?
Yes.
And they served, yeah, I was served court papers. So to settle the whole issue, I have an agreement with them that I am not going to use their software anywhere online. All right.
Okay.
So I am pleading these videos should not be seen anywhere online.
Okay,
all right.
Sir. Yes, sir.
Yeah, because I actually signed some papers with them. And like I said, I have one webinar I took earlier this year. It's a 10-day webinar. I've not been able to share it online. I'm sure it's something that will help a lot of people because it's so detailed. It's advanced. It's not basic. It's actually very advanced. But I couldn't share it. I couldn't share it. So what I'm thinking is maybe someday I will just upload it on YouTube and stream it. So whoever is going to view it will have to view it live. And after the streaming, I'll take it down. And I'll continue like that, for the other 10 videos. But I will not leave it anywhere on the internet. So please,
Yes, sir. Noted, sir.
This information, I take this one very, very seriously. Please don't share it anywhere online. Thank you.
Thank you.
Okay, any other question? Yeah. No other question.
No other question. No other question. I guess. Just first of all, raise a hand if you have a question.
Please, I have a question.
Okay, go on, please.
Thank you very much, sir, for the time you took out to teach us this. But I'm still having a basic problem loading the file from the Office pre or post simulator.
Okay. I think Destiny actually. Okay, no, sorry. I'm about answering a different question. So your own question is that you're having issues loading the data. You were not in the class yesterday, right?
Yes, I was late, sir.
You were late, so that's the problem. You need to talk with Mr. Destiny and his team. They're going to handle that. We can't go back to that today. Okay, so.
Okay, thank you.
Yeah, thank you everyone for listening. Thank you.
Thank you so much,
any other
sir.
question? All right.
I think that
I
would
appreciate
be.
this opportunity.
I think that would be enough for now, sir.
Yeah. All right.
Thank you so much, sir.
Okay. Right. So we've come to the end of this class. Thank you very much, everybody. Thank you, Mr. Destiny and Food.
Okay, so guys, I want to let me quickly give you some more information before we go. Yeah. So this is our next program, and it's going to be very, very, very interesting. So you want to make sure you mark it down in your calendar. It's actually from Thursday next week to Saturday. So we are going to be looking deep into it's one thing, it's why it's important you understand the fundamentals, right? It's important you understand the mathematical principles behind reservoir simulation. And this class was a wonderful introduction to reservoir simulation using the tool, the software. But this particular class will be looking at the fundamental concepts, and it's going to be interesting despite the fact that it's mathematics. So make out time to attend this class, and ensure you have registered for it if you haven't. So thank you guys for participating. Now take note of this. The assignment will be provided later today. later tonight. So you have to finish up the assignments before you'll be given your certificate. Yeah, for those, that is for those who have made their payments. And for those who are yet to make, we have shared the link to make your payments. And please note, from tomorrow, the fee is just 10 US dollars, right? So you make your currency conversions, to your respective currencies, right? So we are almost done. But I want to know if you still have issues with the software, or if you have installed the software, rather, what I would just advise you do, be kind enough to share with others how you went about it in the group chat, or how you did it. So please just share with others. For now, we don't have any license file that works, right? So if you have if you know what to do about that, be kind enough to share with others in the group chat, right? So thank you very much once again. Remember to stay with us. We are going to bring high quality trainings your way. Many of them will be paid, and some of them will be paid, while a number of them will be free of charge. So if you want a full detailed training, you have to touch your pocket a little bit, right? So please stay with us. So don't if you're not going to miss an update, stay with us. In our Telegram group, we've shared the link in our LinkedIn pages, social media pages. Ensure you stay with us. So thank you once again, and it's nice working and learning with you guys. So I hope to see you next week. The recording will be sent, but hopefully next week, not this week. So take note of that. Thank you, and stay blessed.
Okay, sorry, before you go, Destiny,
okay,
if I can, right?
Yes.
Yes, about the software installation.
Yes, sir.
I don't know if it continues. I mean, if people continue to have that issue, please let me know. Maybe I'll just create a video, and like I said, the video is just going to be streamed, and after the streaming, it goes off. Okay. So everything that has to do, everything that has to do with software, I am not going to do software installation or usage. I'm not going to leave it online, but I can stream. So once I stream, we won't be able to keep record. So maybe sometime, maybe during the week, I'll upload the video, but it's going to be uploaded. It's going to be streamed on my YouTube channel, right?
All right, sir. All right.
Yeah. So you can share that information as well, so that I'll share the link. I'll send the link to your people to download it and follow the instructions on the video. Then I'll take it down. So that way, I think it can help some more persons. That is, if you continue to have that problem. Yeah.
All right. Okay. Thank you so much, sir. Thank you very much, guys. Please drop a comment in the group chat if you love the class, you benefited from the class. Drop a comment, or you drop a post on social media, and just ensure you acknowledge, acknowledge that or testify that you've gotten something from the class. So we love to see your feedbacks. We love to see your comments. Please don't forget this, right? Thank you. Stay blessed.